Hello. If you appreciate clear and simple explanations of complex technology, please like and subscribe. Today, we are going to demystify one of the most talked about topics of our time: artificial intelligence. We will explore exactly what it is. We will explore how it functions. We will explore the real-world impact it is already having on our lives. I will break down the pros and cons in a straightforward way. I will use examples you already know. My goal is to keep this discussion short. My goal is to keep it easy to understand and free of confusing jargon. We will cut through the hype and get to the core of what AI means. For you, for business, for society as a whole. Artificial intelligence, or AI, is a term you hear everywhere, but its true meaning is often misunderstood. It is not about sentient robots taking over the world. Rather, it is about creating software that can perform tasks that traditionally require human intelligence. For example, recognizing a face in a photo, translating a sentence from one language to another, suggesting the fastest route to your destination. These are complex cognitive processes that we're teaching machines to perform. At its heart, artificial intelligence, or AI, refers to the simulation of human intelligence in machines. These are computer systems programmed to think, learn, problem-solve in ways that mimic human cognitive functions. It is not a single monolithic entity, but rather a broad field of computer science encompassing many different tools, techniques, approaches. Some forms of AI are relatively simple, designed to follow a strict set of pre-programmed rules to accomplish a specific task. Others, which represent the cutting edge of the field, are capable of learning and adapting on their own, improving their performance over time as they are exposed to more information. When we talk about AI today, we are often referring to a subfield called machine learning. This is the technology that allows a computer system to learn from data without being explicitly programmed for every possible scenario. Instead of a developer writing code that says, "If you see these specific pixels, it's a cat," the developer creates an algorithm that can learn the concept of cat by analyzing thousands or even millions of example pictures. This ability to learn from experience is what makes modern AI so powerful and versatile, enabling it to tackle problems that were once considered impossible for machines to solve. Let me give you a very simple, everyday example that you have likely encountered. Imagine you open your phone's photo gallery and search for beach. Within seconds, the app displays every photo you have ever taken that contains a beach scene, even if you never manually tagged them. This is AI at work. The app uses an image recognition model that has been trained on a vast dataset of images. It has learned to identify the visual patterns associated with beaches, sand, water, waves, horizons. This is not magic. It is a computational process of pattern recognition that feels intuitive to us. So, to put it plainly, AI is software that can perceive its environment, think about what it perceives, and take action to achieve a specific goal. In the beach photo example, the AI perceives the pixels in your images, thinks by comparing them to learn patterns, and acts by showing you the relevant photos. This core loop of perceive-think-act is the essence of artificial intelligence. The process of how an AI system learns can be broken down into three fundamental and interconnected components: data, training, algorithms. Each step is absolutely critical, and the quality of the final AI model depends heavily on the strength of each link in this chain. Think of it as a recipe for creating intelligence. First, you need the ingredients, which is the data. Then, you need the cooking process, which is the training. Finally, you need the recipe instructions themselves, which are the algorithms. Let's explore each of these elements in more detail to understand how they work together to create a functional AI. First, we have data. Data is the lifeblood of modern artificial intelligence. It is the raw material from which the AI learns. Images, text, audio recordings, numerical spreadsheets. For our example of an AI that identifies dogs in pictures, the data would consist of a massive collection of photographs. Crucially, this data must be labeled. This means a human has gone through the images and marked each one, indicating dog or not, a dog. Quality, quantity, accuracy. If the data is biased or incorrect, the AI's knowledge will be flawed from the start. Next comes the training phase. Training is the process where the AI model actually learns from the data it has been given. During this stage, the model, guided by an algorithm, repeatedly analyzes the labeled examples and tries to identify the underlying patterns. It makes a guess for each example. Is this a dog? And then compares its guess to the correct label. If the guess is wrong, the model makes a small adjustment to its internal parameters to improve its accuracy for the next attempt. This process is repeated millions or even billions of times, often requiring powerful computers running for hours or even weeks. Finally, we have the algorithms and models. An algorithm is the set of rules or the step-by-step procedure that guides the learning process. It defines how the model should adjust itself in response to errors. The model is the final output of the training process, a complex mathematical structure that encapsulates all the patterns it has learned from the data. One of the most common types of models used today is a neural network, which is loosely inspired by the structure of the human brain. It consists of layers of interconnected nodes, or neurons, that process information. When combined, these simple units can learn to recognize incredibly complex patterns. To make the concept of AI training even clearer, let's use a simple analogy. Imagine teaching a young child to distinguish between apples and oranges. You start by showing the child a piece of fruit and clearly stating its name. This is an apple. Red, round object. This is an orange, bumpy, orange-colored sphere. These fruits are the data. The child observes color, shape, texture, size. The child guesses, you correct, they adjust their internal rules. Over time, big apples, small ones, green apples, blood oranges, they become accurate. They have been trained. This is exactly what happens inside a computer during AI training. Guess, check, correct, repeat. One of the most significant benefits of artificial intelligence is its ability to operate at a speed and scale that is simply impossible for humans. An AI system can analyze millions of documents, sift through thousands of hours of video footage, process vast data sets in minutes. This capability transforms scientific research, accelerating drug discovery by analyzing complex molecular interactions. In the legal profession, AI can review mountains of case law and contracts to find relevant information far faster than paralegals, freeing experts for strategy and decision-making. AI also automates repetitive, mundane tasks, liberating human workers. Data entry, filling out forms, scheduling appointments, managing inventory. AI handles these with speed and accuracy, reducing errors and boosting productivity. Employees move to creative, collaborative, strategic work. Skills like empathy, critical thinking, innovation. AI finds subtle patterns humans miss, driving data-driven decisions. In finance, AI detects fraudulent transactions in real time by spotting unusual spending. In healthcare, AI analyzes medical images, X-rays, MRI scans, to spot early signs of disease like cancer, sometimes more accurately than the human eye. That means earlier interventions, better outcomes, saved lives. AI fuels everyday services. Voice assistants, Siri, Alexa, understand our spoken commands. Real-time translation breaks language barriers. Recommendations on Netflix and Spotify surface content tailored to you. In transportation, AI powers self-driving cars, promising safer roads, greater mobility for everyone. Despite its immense potential, artificial intelligence is not without its significant risks and limitations. A primary concern is the old adage, garbage in, garbage out. An AI system is only as good as the data it is trained on. If the training data is incomplete, inaccurate, contains hidden biases, the AI model will inherit and often amplify those flaws. For instance, if a facial recognition system is trained predominantly on images of people from one demographic group, it may perform poorly on others. This can lead to unfair or discriminatory outcomes, eroding trust and causing real-world harm. The widespread adoption of AI also raises serious concerns about job displacement and economic disruption. As AI becomes more capable, certain job roles, particularly those involving routine data processing or manual labor, are likely to shrink or become obsolete. While new jobs will be created, the transition could be difficult, necessitating massive efforts in retraining and education. Privacy is another major issue. Many AI systems rely on vast amounts of personal data, from your search history and location data to your online purchases and social media activity. Collection and storage at scale create significant risks of misuse. It could be used for invasive surveillance, social manipulation, or be compromised in a data breach. Furthermore, many advanced AI systems suffer from a lack of transparency, the black box problem. A model might deny a loan application yet be unable to explain why, making auditing and fairness checks difficult. When stakes are high, an unexplainable answer is often an untrustworthy one. The question of whether we should trust artificial intelligence is not a simple yes or no matter. Trust in AI is not absolute. It is contextual and conditional. The level of trust depends on the specific task and the stakes involved. We already place high trust for low-risk, high-convenience tasks. If a movie recommendation is wrong, consequence is minimal. We might waste 2 hours. Low risk, low required trust. Consider high-risk applications, medical diagnoses, self-driving cars. Mistakes can be life-altering or fatal. Trust can't be given freely. It must be earned through rigorous validation. It must involve transparent processes and a clear understanding of capabilities and limitations. We wouldn't trust a new drug without clinical trials. We should scrutinize high-impact AI the same way. Verify with comprehensive, continuous testing in real-world scenarios, including edge cases that push the system to its limits. Demand a degree of transparency. Design critical AI to be interpretable, able to provide rationales for conclusions, like itemized reasons in a credit decision. Never trust AI completely on its own in high-stakes situations. The safest models involve human oversight. AI as a powerful assistant, the final call by a responsible expert. Human in the loop combines the machine's speed with the judgment, ethics, and common sense of a person. To make AI a technology we can rely on, we must proactively build a framework of trust around it. This framework rests on several key pillars, starting with robust testing and validation before deployment, exhaustive testing across conditions. After deployment, continuous monitoring to catch degradation or emerging biases. This is the first line of defense. Another pillar, clear rules and regulations. Governments and industry bodies must set legal and ethical guardrails that protect rights, ensure privacy, and mandate accountability. Require transparency about when and how AI is used, especially for decisions that affect people's lives. Most important, human oversight. For significant consequences, medical diagnosis, parole, loans, a qualified human must remain in the loop. Cultivate responsible data stewardship, comprehensive and unbiased data sets, strong security and privacy-preserving techniques, and transparency about data collection and use. Use AI where it provides clear benefit, where performance can be verified, and where decisions face meaningful human review. In summary, artificial intelligence is a powerful present-day tool reshaping our world. Built on data, training, and algorithms, it delivers speed, scale, and pattern recognition. Benefits are vast, but risks, bias, job displacement, privacy erosion, black boxes, demand attention. Trust is earned through testing, regulation, and human oversight. If you found this explanation helpful and wish to continue learning about the technologies shaping our future, please like this video and subscribe for more clear, simple explainers. Thank you for your time.